Hello, Calculus 12 students, and welcome to the second part of the video tutorial for the final exam. And in this video tutorial, I will be solving some of the questions based on the calculator portion of the practice exam. Okay, so let's jump right into this, and I will start off this video tutorial by going over the second question in the review package. And in this question, I have a word problem here. It's probably another application of derivative word problems. And let's take a look here. So I have a farmer who wants to enclose a rectangular pasture of 500 square meters. And for this problem, 3 sides of the pasture will be enclosed with cedar fencing at a cost of $10 per meter. Okay, and the remaining side is to be enclosed with a stone wall at a cost of $15 per meter. Okay, and then I want to find out what should the dimensions of the field be in order to minimize the cost of the enclosure. Okay, so I want to minimize the total cost of the structure, so I need to make some kind of a mathematical expression to relate the length and the width and the cost of the length and the width so that I can take its derivative and set equal to 0, because that's how you minimize the total cost. Okay, so in order to do a problem like this, let's go ahead and just draw a diagram here. Here's my rectangle pasture right here, and I know that 3 sides of the rectangle pasture right here, the 3 sides will be charged at $10 per meter. Okay, so this might be my width right here, and this might be the other width, and let's call this the length, and that means this length, which is I put a red L there to indicate that that's the side that's going to be built as a stone wall, and that's going to cost $15 per meter. Okay, so let's write out an expression for the total cost now. Alright, so for this width right here, the total cost of that is going to be 10 times the width, because it's $10 per meter, plus, now the total cost of this width will be $10 times the width, plus, and this length right here would be $10 times the length, plus, this length over here, that's the stone wall, so that's going to cost $15 times the length, and so this gives me the mathematical expression for the total cost. Okay, so let's just kind of simplify this. Total cost, I'll just use the letter C now. So C is going to be 20W plus 25 times L. Okay, now I want to find the derivative of this expression right here, but the problem is I have too many variables. I have a W here and I have a L over there. So the goal is I want to eliminate one of those variables by using a different equation, and then I want to find its derivative. In order to eliminate one of the variables, I need to find another mathematical formula that kind of relates the length and the width, and we can do that by analyzing this 500 square meters here. And 500 square meters basically means that the area is going to be length times width, but the area is simply going to be 500. Okay, so I know that the area is 500, and that's equal to the length times the width. Okay, so what I'm going to do here is I'm just going to go ahead and eliminate the W here. So let's go ahead and solve for the W here. The W is going to be 500 divided by the length. And it doesn't really matter which variable that you solve for. I'm just going to eliminate the W there. Okay, if I go ahead and do that, this is going to be 20 times 500 divided by L plus 25 times L, and that's going to equal to my total cost. Okay, so I'm just substituting this expression right here with that W right there. Okay, so let's go ahead and apply some algebra here. This is going to be I guess if I take this 20 and times it by the 500, I should get 10,000 divided by L plus 25L. Okay, and I'm going to rewrite this as C equals to just 25L plus 10,000 divided by L. Okay, now we can take its derivative. Alright, so I'll write down C as C prime. So C prime is going to equal to 25. Now this L right here, we can replace this L as L to the power of minus 1, and then if I take its derivative, it's going to be negative 10,000 L to the power of minus 2. And if I want, I can delete this L to the minus 2 here, delete all that, and I can write that as negative 10,000 divided by L squared. Now we want to minimize the total cost, so if you want to minimize or maximize anything, we got to take its derivative and set it equal to 0. If I do that, I get 25 equals to 10,000 divided by L squared, and that means L squared equals to 10,000 divided by 25, and then I can take the square root of each side, and then if you go to your calculator, this should give you a length of 20 meters. Now if your length is 20 meters, you can simply find your width by going back to your area formula here, and you can take this L of 20 meters and you can change L to 20 meters and just solve for your width, and your width will be 25 meters. Okay, so your length is 20 meters and your width would be 25 meters, and those are the dimensions that would minimize the total cost of the enclosure. Okay, let's move on to another question here. Now we're moving on to some related rate problems now. For this question, the radius of a bubble is 3 kilometers. So there's a little typo here. Let's get rid of that extra s. So the radius of a bubble is 3 kilometers. So let me just write that down. R is equal to 3 kilometers. And it is expanding at a rate of 12 kilometers per hour. Okay, so the radius is expanding at a rate of 12 kilometers per hour. Okay, determine how quickly the volume of the bubble is increasing. And the volume of a sphere of a radius is 4/3 pi r cubed. Okay, so that's pretty good. They give us the volume formula, which is 4/3 pi r cubed. This is the volume of a sphere, and I want to find out how quickly the volume of the bubble is increasing. So I want to find out what dV by dt is. Okay, so I want to find out how quickly the volume of the bubble is increasing, so that means I'm looking for, yes, dV by dt. Now in order to get my dV by dt, I just take my volume formula here and I take its derivative. So this will be dV divided by dt equals to 4/3 pi, that's just a constant, and then I have this 3 right here. If I take the derivative, this is going to be 3 times r squared times dr by dt. Okay, and all I have to do now is just plug in the numbers here. This is 4/3 times pi times another 3. And what's the radius here? Well, the radius, we've already found the radius in the problem. It's going to be 3 kilometers, so this will be 3 squared, and dr by dt is going to be 12. Okay, so after that, I just go to my calculator and then I can find my final answer here. We can go ahead and simplify this. Those cancel out. So this is going to be 4 times pi times 9 times 12, and if I go ahead and go to my calculator here, this is going to be 432 pi. Alright, so that is the how fast the volume of, that's how fast the volume of the bulb is increasing, given the information, given like the information in this question here, I guess. Okay, so that question's not too bad. You just take the derivative of your volume formula here and you just plug in the numbers. Pretty easy, that one. Okay, the next question here. Cars A and B leave a town at the same time. Car A heads due south at a rate of 80 kilometers an hour, and car B heads due west at a rate of 60 kilometers an hour. How fast is the distance between the cars increasing after 3 hours? Okay, so I know that car A is going due south. Okay, so car A is going due south. This is car A. And I know that car B is going due west. So this is car B going in this direction here. We'll call that just car B. And I want to find out how fast is the distance between the cars increasing after 3 hours. So the distance between the two cars is actually this red line right here, okay? So if I went ahead and labeled this as a Y here, and if I labeled this as an X, and maybe we'll call this letter Z here, the question is, I want to find out how fast Z is changing with respect to time after 3 hours. So basically I'm looking for what is dz by dt. That's what I'm looking for. I'm looking for the rate and change of that distance. Okay, so the mathematical formula that's going to relate car A and car B and this distance z is going to be the Pythagorean theorem. So this will be x squared plus y squared equals to z squared. All right, and then for these related rate problems, we just take its derivative. So this will be 2x times dx by dt, because I'm taking the derivative with respect to time for all these related rate problems. So I need to apply implicit differentiation here. So the derivative of x is going to be dx by dt, and then same thing over here will be 2y times dx by dt, and this one will be 2 times z, and then dz by dt. And my goal is I want to find out what this dz by dt is. Okay, so all the 2's can just cancel off here, and then all we have to do is find the values of x, the value of y, and the value of z. Once we find the values for those variables there, then we can find dz by dt. Alright, so let's just kind of delete this information here, and let's just relabel the diagram now. Now, I know that car A is heading due south, and it goes at a rate of 80 kilometers an hour. So 80 kilometers an hour, that's going to be, sorry, I made a mistake here. This is a dy by dt. So I know that dy by dt is going to be 80 kilometers. Now, if I go for 3 hours, that means the total distance is going to be 240 kilometers, right? So 80 times 3 is 240 kilometers. And if my car B is going at 60 kilometers an hour, that's going to be dx by dt. If I'm going 60 kilometers an hour, and after 3 hours, that's going to be a total distance of 180 kilometers. All right. Now, if I go ahead and use the Pythagorean theorem here to find the total distance z, that's going to be 180 squared plus 240 squared equals to z squared, and that means that my z value is going to be 300, and you can verify that using your calculator. Okay, so let's go ahead and plug the numbers now into my mathematical equation over here. The value of x here is going to be 180, because I got 180 kilometers after 3 hours, and I'm going a distance of my rate is going to be 60 kilometers an hour, plus the value of y is going to be 240, and my dy by dt is going to be 80, and that's going to equal to z, which is going to be 300 times the dz by dt. Okay, let me just kind of clean this up over here. And after that, we can just go to our calculator right here and calculate each expression here. 180 times 60, I believe that's going to be 10800, plus 240 times 80 is going to be 19,200, equals to 300 times dz by dt. And if we do the math here, dz by dt is going to equal to about 100 kilometers an hour. Okay, so that's the solution for that problem. Okay, let's move on to the other related rates problem here. This one's going to be maybe a little bit more challenging. I have two cylindrical swimming pools, and they're being filled with water at the same time, and that's going to be measured in meters cubed per minute. Okay, so these two swimming pools are being filled with water at the same time, at exactly the same rate measured in meters cubed per minute. Okay, the smaller pool has a radius of 5 meters. Okay, so let me write that down. I know that the radius of the smaller pool is going to be 5 meters. Okay, and then the height of the water in the smaller pool is increasing at a rate of 0.5 meters per minute. Okay, so that means the height is increasing at a rate of 0.5 meters per minute. Okay, great. Now we have some information about the larger pool. The larger pool has a radius of 8 meters. Okay, so that means the radius of the bigger pool has a radius of 8 meters. And I want to find out how fast is the height of the water increasing in the larger pool. Okay, so I want to find out what dH by dt is for the bigger pool there. Okay, great. Let's kind of draw a diagram kind of indicating what's going on in this kind of problem here. I have these two cylindrical pools here. We have a small one and we have a big one. I know the volume for one of these cylinders is going to be pi r squared h, and this one will also be pi times r squared h. So this will be the small guy, and this will be the big guy. Okay, great. All right, so I want to find dH by dt. Now, a very important piece of information in this problem is actually the very first sentence. Okay, so let me just highlight this all in blue here. These two cylindrical swimming pools are being filled simultaneously with water at exactly the same rate, measured in meters cubed per minute. Okay, so this guy right here is a volume expression. Okay, so what that's saying right there is if I find the volume, if I find dV by dt, the rate of how the volume is changing with respect to time, I know that the dV by dt over here is going to be equal to the dV by dt over here. Okay, so those two rates are equal because the problem tells us that. Alright, so the volume in which the big and small pools are increasing is actually increasing, or it's actually being filled at the same time, so dV by dt has to be equal for both situations there. Okay, so let's go ahead and find out what dV by dt is. So if I go ahead and take the derivative right here, which is dV by dt, this is going to equal to pi r squared times dH by dt. Okay. Now, one of the reasons why I'm not taking the derivative of this r squared term, even though there's a variable there, is because the radius is constant, right? The radius will never change in this problem for that small pool. Okay. Now, that means dV by dt over here for the big guy, the radius over here will also not change. So if I find the rate of the volume if I find the derivative volume with respect to time, this is going to be pi times r squared times dH by dt. Okay. Now, since dV by dt, since those two rates are equal, I can take this expression right here and make it equal to that expression over here. Okay, so let's do that to kind of get this problem rolling here. So I know this is going to be pi times r squared times dH by dt. So this is the small guy, the small pool, and that's going to equal to the bigger guy, which is going to be pi r squared times dH by dt. So this is the big pool right here. Okay. Alright, so our goal is I want to find out how fast the height is changing with respect to time for the larger pool. Okay, so I know that this is going to cancel off, that's going to cancel off. What is the radius of the smaller pool? Well, the radius of the smaller pool is going to be 5 meters, so this will be 5 meters squared times dH by dt. And what is dH by dt? Well, that's going to be 0.5 meters, minutes per meter. Alright, and then we can make that equal to the radius of the bigger pool, and the radius of the bigger pool is going to be 8, so this will be 8 squared times dH by dt. Okay, so not too bad there. And then after that, we just solve for dH by dt, so dH by dt is going to equal to, 5 squared is going to be 25 times 0.5. all divided by 64. So this is going to be about 25 divided by 128 meters per minute. Okay, so there's the answer for that problem right there. 25 over 128. Okay, let's move on and let's take a few antiderivatives now that we've done a few of those word problems. I'm just going to go ahead and just kind of write the final answers for these kind of problems. I think most of you will be okay with problems like these. So this will be x to the power of 5 minus x to the power of 3 plus x squared plus 6x plus c. Alright, so remember we're just using the power rule, so for all your exponents just add 1 to them and then divide by your new exponent, and that's what you should get once you're all done. Okay. For the next question here, this is going to be a u substitution question. So I'm going to let u equal to my exponent there. So if I let u equal to 5x squared minus 1, and then I'm going to go ahead and take its derivative. So du by dx, this is going to be 10x Okay, and then if I go ahead and let me just kind of replace the original question with this integral sign, bracket x e to the u times dx. Okay, so notice that I have an x here and I have an x over there, so I can change this around, and I'll make this 1 over 10 times du equals to x times dx. Okay, so I have an x and a dx over there, so I can kind of line up those with those guys. So the x and the dx, I'll change that with 1 over 10 du. So this is going to be the integral of, I'll put the 1 over 10 in front with the Superman sign. This will be e to the u times du. Okay, so hopefully hopefully you can see the substitution step there. I'm just changing the x and the dx with 1 over 10 times du, and I brought the 1 over 10 in front. Okay, so then we can go ahead and take the antiderivative of this expression right here. So this is going to be 1 over 10, and the antiderivative of e to the u is going to be e to the u plus c. And then if I go ahead and substitute my u again, I have 1 over 10 e to the 5x squared minus 1 plus c, and this will be my final answer right here. Okay, so that's the basic u substitution question. Okay, let's move on to the next problem here. Now for this next problem, one thing that you may want to kind of look up on your formula sheet is that 1 over x squared plus a squared dx, that is going to equal to 1 over a times the inverse of tan of x over a plus c. Okay, so for this kind of problem, let's just kind of rewrite this as 3. I brought the 3 on. I brought the 3 on the outside there, and if I do that, I'll get 1 over. And then for the denominator here, let's rewrite this as x squared plus 3 squared dx. Okay, so now we've got to find the antiderivative of this expression right here, and I can definitely use this identity over here, or that formula right there, to help me find the final answer. If I go ahead and finish this off, this is going to be 3 times, well, this is going to be, the value of a here is going to be 3, so this will be 1 over 3 times tan inverse of x over 3 plus c. Okay, and if you want to go ahead and just we can also just simplify the 3's there, and I should get tan inverse 1 of x over 3 plus c over there. Okay, so that's my final answer for that problem there. Let's move on with the next question here. Another antiderivative here, and this is another u substitution question here, so let me just zoom in here. Okay, so for a question like this, I will let my u value be ln x. So u equals to ln x. Alright, so if I do that, this integral now changes to the integral of 1 over x times u to the power 3 times dx. And as I mentioned in class many times, if you have a dx over here, that means everything on the inside must also have a variable x. So I have an x here and I have a u there. So obviously we have some problems there, and we need to change or make a substitution step here in order to get rid of that bottom x there. In order to do that, I need to, one thing that I could do is I can change this dx to a du. So in order to do that, I can change, or I can take the derivative of u here. So du by dx is going to be 1 over x. Okay. The good news is this x over here is that x over there. So I can just simply kind of move this around. So this will be du equals to 1 over x times dx. Alright. So you'll notice that this x and this dx, you can find that all back in the original equation there, or that integral expression, sorry. Alright, so let's go ahead and simplify this. This will be the integral of 1 over u cubed times du, which is the same thing as the integral of u to the power of minus 3 du. Alright. Notice I have a u here and a u there. That means I'm in a pretty good situation now in order to take the antiderivative. So let's go ahead and find the antiderivative. Let's just add 1 to my exponent here. So this will be u to the power of -2 divided by -2 plus c. And then all we have to do now is plug in the value for u there. U in this case was ln x, so this would be ln x -2 all over -2 plus c. Right, and that would be my final answer for that question there. So that one's not too bad. Okay, let's move on to the next one. This one we have a definite integral here because I have a upper bound. I have an upper bound and a lower bound here. Now if I go ahead and graph this, I know 2x kind of looks like this. And if I want to take the absolute value, that means this part right here will be reflected. So I'm going from here to here now. So let's just delete this part right there. Whoops. Alright, so I want to find out what my area is between -1 and 2. So I want to go ahead and find that area right there. Okay, so in order to do this, let's go ahead and set up an integral for this yellow area right there. That's going from -1 to 0, and this is actually going to be -2x dx plus the integral from 0 to 2 now, because I'm looking for the area of this blue triangle now, and that's going to be just 2x times dx. Okay. Now before you go to your calculator and get the final answers here, you should take the antiderivative here. So this will be -2 x squared divided by 2, and that's going from -1 to 0, plus 2x squared divided by 2 from 0 to 2. And after that, you can go ahead and just tell me the final answer here. If you go ahead to your calculator, I think the final answer here should be 5, so you can verify that using your calculator. Okay, great. Let's move on to the next one. Find the average value of y equals to sine x on the integral from 0 to pi. Alright, so make sure you know this for the final exam. The average value can be found using this formula right here, 1 over b minus a, from the integral from a to b of f of x dx. Alright, so let's go ahead and find the, let's go ahead and plug the numbers here. This 0 is going to be my a, this is going to be my b, so this is going to be 1 over pi minus 0. I'm going from sorry, I just realized that my formula is wrong here. I'm just going to delete this here. Hold on. This will be sorry, a is on the lower bound here, and b is on the upper bound, so this will be 0 to pi of sine x dx. Okay, and if you go ahead and find the antiderivative of this expression right here, that's going to be a negative cos x, and I'm going from 0 to pi, and don't forget my 1 over pi in front. And then I just need to evaluate. If you go ahead and evaluate this and times that by 1 over pi, then you have your final answer. This isn't too bad here. I mean, this is going to be 1 over pi. Now this is going to be negative cos of pi plus cos of 0. I think most of you, if you take your pre-calc 12, you can probably figure this out here. This is going to be a value of 1. Plus this will be a value of 1, so this is the final answer here should be 2 divided by pi. So don't forget this pi over here. So the final answer is 2 divided by pi, or go right to your calculator there. Alright, let's move on. Okay, let me just kind of zoom out here. The graph of g prime of x is graphed below. And for this question, I tell you that g of -3 is 3 and g of 4 is 6. I want to sketch a possible graph of g. Okay, so this is going to be g prime of x. Okay, now when you're given the antiderivative, and if you want to graph the original function, step number 1 is you want to find the x-intercepts. So find your x-intercepts. And what you want to do is you want to draw a vertical line at those x-intercepts. Here we go, vertical lines and vertical lines. Okay, Now what you want to do is, we've divided the graph into a few sections here. Ask yourself if the graph is below or above the x-axis in each section here. So over here, I know this graph, that piece of the graph right there is below the x-axis, so I'll put a negative sign here. And then this part right here in blue, that is above the x-axis, so I'll put a plus sign above there. And then this next part in green, that's going to be below the x-axis, let's put a minus sign there. And then this part here in blue, that's going to be above the x-axis, so let's put a plus here. Okay, let's delete the colors now. Okay, so if I'm going from like a negative to a positive, that means I have like a minimum value at this vertical line right there. And if I'm going from a positive to a negative, that means I have a maximum at that line right here. And if I'm going from a negative to a positive, that means I have a minimum over here. Okay, so let's go ahead and put these minimums somewhere on this vertical line here. Let's just put the minimum down here just for fun, and let's put the maximum over here on that guy there, and a minimum somewhere over here. And let's go ahead now and finish the graph here. Okay, so this means I have a negative slope, so that means I'm going down, and then I connect to this guy right here, and then I want to go up here, and then I have a positive slope, so this is all positive. I connect there, then I have a negative slope there, so I go down there, connect to that point there, and then I have a positive slope, something like that. So my graph will look something like this here. Let me just kind of delete all these vertical lines now. Okay, so that red graph there could be a possible sketch of f of x. Now the only problem is that I need to go ahead and fill the criteria of this and this. So this means when x is equals to 4, I should have a height of 6. So let's just pretend that if this is x is 4, let's just say this is the point 4 comma 6 there. And also I have a negative 3 and a 3. So I kind of botched this guy over. I botched that graph over here. So let me just put another vertical line right here. And this should be somewhere like that. So I have a negative slope, so maybe my graph could look like this. There, and slowly like that. Okay. Alright, so this would be a better answer for the criteria that's given to me. This is going to be 4 comma 6, and this is going to be, this point right here is going to be negative 3 comma 3. Alright, so there you go. I'm going to stop the video right now just because I'm running out of energy right now, and it's probably a better idea for me to kind of produce these videos with a better effort here. So let me just kind of stop the video here, and then I'll continue on with the part 3.